Hello people, in this video, we'll see how to use the Orbital Tools add-on and its OrbitalObject3D node. Once downloaded, extract the file and you'll have two folders: Orbital Tools and Environment and Camera. The first is the add-on, and the second is an extra folder for testing. Open a new project in Godot engine, and once it's running, create a new folder in the root directory called add-on. Copy the downloaded Orbital Tools folder into this new folder. Once the add-on is loaded, go to Project, Project Settings, Plugins, and enable the Orbital Tools plugin. Then, for it to take effect, it is necessary to restart the program. Go to Project, reload current project. Now you can create the 3D scene, and when you add a node, you'll find the OrbitalObject3D node, which is the main node, and the OrbitRender3D node, which is an accessory for visualizing the orbits. Add an OrbitalObject3D node, and in the output, you'll see that it indicates it's a body without an attractor. The orbit isn't calculated because the parent node isn't an OrbitalObject3D. The accessible properties are mass, radius, initial position, and initial velocity. If you add another node as a child of the first, this one will calculate the orbit, and the parent node will act as the attractor. For the calculation, you'll need to define the orbiter's velocity and position. If you want to see the node's documentation, it's not included due to a bug in Godot. You need to open the node's script, make a minor modification, like adding a space, and save. Then you'll be able to access the documentation, where you'll see all the available properties and methods, as well as a description of how it works. There is also a singleton called the Orbital Manager, which contains the gravitational constant used for calculations. This constant has the actual value, but you can modify it as needed. Additionally, there are functions for time scaling and for accessing the simulation time in seconds. Since we are using the actual gravitational constant, g, we have to use a very large mass value for the attractor. Then we can assign position and velocity to the orbiter and obtain the orbit calculation. The output shows an elliptical orbit with a given period and eccentricity. If we increase the velocity, we obtain a hyperbolic orbit with an eccentricity greater than 1. Now the objects aren't visible. We need to add a renderable object, which can be anything. For this example, we'll add spheres. The scene still won't be visible because it's missing a camera. Along with the add-on, I've shared a folder you can add to have a moving camera in a space environment. Now we can run the simulation, and we see the planet orbiting the sun, but it's very dark. Let's add a light source to the sun. We can add the second node of the add-on to the simulation, which is OrbitrRender3D. This allows us to see the orbital trajectory. You must add it as a sibling of the orbiter node and assign it that OrbitalObject3D in the properties. You can also change the color and the number of segments of the curve. Let's add a second planet to the system. The number of orbiters isn't limited, and you can add other orbiters to each orbiter, which could be moons, satellites, spacecraft, or anything else. Let's add a moon to Planet 2. Since Planet 2 will now be the Moon's attractor, we must give it a large mass value, but less than that of the Sun. We assign the Moon's position and velocity, and its orbit is calculated. Notice that the coordinate base is rotated. It aligns with the peripheral plane of its attractor. Recalculating Planet 2's orbit, we see that it now has a radius of influence of 46. Let's add an OrbitrRender3D. The orbit is elliptical, but it escapes the planet's zone of influence, eventually orbiting the Sun. I correct the velocity so that it remains in orbit. Orbiter transfers when entering or leaving zones of influence are automatic. With this tool, you can simulate real systems like our solar system and then scale distances for rendering. These are some of the possibilities of this add-on, which you can download from ith.io. Other features such as script usage and time scaling are explained in the manual. Thanks for watching the video, and feel free to leave a comment with any questions or suggestions on this channel or on my X account.